Hi everyone, I'm Dr.J Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about binomial distribution. Before going to discuss about this distribution, binomial distribution, we need to know some basic concepts on this distribution. In this basic concept, first we have to know what is Bernoulli trial. What is the meaning of Bernoulli trial? I will explain you with a simple example what is the meaning of Bernoulli trial. Suppose tossing a coin. Tossing a coin. Is it random experiment or not? Yes, it is a random experiment because we cannot predict the result if we toss a coin. Either head comes up or tail comes up. See, if we toss a coin, what are the possible outcomes? Head or tail? Only two possible outcomes. Only two possible outcomes. If you assume head is a success, tail is by default, it is failure. Totally, how many possible outcomes? Only two outcomes, which are success and failures. Then this random experiment is known as Bernoulli trial. Bernoulli trial. It is a random experiment. Bernoulli trial is a random experiment having only two possible outcomes, which are success and failure. Suppose if I take another example, throwing a die. This is also random experiment because if we throw a die, either 1 comes up, 2, 3, 4, 5, 6. So result we cannot be predicted. So that's why it is a random experiment. What are the possible outcomes? 1, 2, 3, 4, 5, 6. If you assume getting 1 is success, then remaining all are failures. Yes or no? If I am assuming getting 1, if we throw a die, is a success, then remaining all phases 2, 3, 4, 5, 6 are failures. How many possible outcomes? Only 2 here also. Either success or failure. Either success or failure. So that type of random experiment is known as Bernoulli trial. So blindly you remember that it is a random experiment having only two possible outcomes, which are denoted by success and failure. So probability of success, P of S, which is denoted by P, and probability of failure, which is denoted by Q. If you add these two, we'll get 1. Probability of success plus probability of failure equal to 1. This is for only single trial, each trial. Tossing a coin 100 times. But Bernoulli trial consists of only for one trial. Throwing a die 10 times. But you consider for only single trial. So probability of success in a single trial, probability of success is P and probability of failure is Q. So that is the Bernoulli trial. It is a random experiment having only two possible outcomes, which are denoted by success and failure. The probability of that particular success is P and the probability of that particular failure is Q in each trial. So P plus Q equal to 1. In this Bernoulli trial, we have small n trials. Bernoulli trial means for only single trial. Here we have small n trials and these are the 3 distributions. Binomial, Poisson, normal distributions. So first we need to discuss about binomial distribution. What is the meaning of binomial distribution? What is the purpose to know binomial distribution? What are the applications? What we are going to get by using the binomial distribution? We'll discuss now. See, consider any random experiment. Assume this is a random experiment. like tossing a coin. Assume that this has n trials. Suppose this is the first trial, trial number 1, trial number 2, trial number 3, and trial number m, and trial number 5, trial number 6, and so on. Total number of trials are n. Like tossing a coin n times. Tossing a coin n times. Tossing a coin 10 times. But out of this n trials from 1 to n, not always all are successes. Suppose tossing a coin 10 times. Is it possible to get head 10 times? No. Sometimes maybe head, sometimes maybe tail. If you assume getting head is a success, how many times success? 5 times. Like that, out of n trials, assume that m trials are succeed. Sorry, x trials are succeed. Out of n trials, x times are succeed. So, 1 time success means probability of success is P. Second time success means probability of success means P. Like that, how many times? X times. So, P, first time success P, second time success P, third time success P, up to how many times? X times. So, P into P into P into up to how many times? X times. This is nothing but P power X. If X times are succeed, what about the remaining times? Out of n trials, X trials are succeed. Remaining trials, how many are there? N minus X trials are failure. But probability of one failure is Q. Second failure is Q. Third failure is Q. Like that, how many failures? N minus X failures. That means Q, Q, Q into and so on n minus X times, which is equal to Q of Q power n minus X. So, probability of success getting X successes is P power X. Probability of getting n minus X failures is Q of n minus X, Q power. Therefore, finally, we need to find out probability of getting X successes. P of X equal to X. Capital X is a success. Small x is a number of successes. Probability of success equal to small x. Probability of getting number of successes. The formula in a binomial distribution that P power x into Q power n minus x into NCX. This is denoted by B of binomial distribution of x comma n comma p. Therefore, the binomial distribution formula B of x comma n comma p equal to find out probability of number of successes by using the formula NCX P power x Q power n minus x. Here capital X is success like head in our example. Small x is number of heads. I want probability of getting number of hits are 4 if we toss a coin n times or 10 times. We can use by using the binomial distribution. The symbol is B of x comma n comma p to find probability of number of successes by using this formula NCX P power x Q power n minus x, where P is probability of success in a single trial. Q is probability of a failure in a single trial. Small x is number of successes. Small n is total number of trials. Capital X is success. Okay. Now, suppose what is the total probability in a binomial distribution? See, this is the binomial distribution form. B of x comma n comma p equal to NCX P power x Q power n minus x. If you take x equal to 0, number of successes are 0. x equal to 0, nc 0 because x equal to 0, p power x, p power 0, q power n minus x, where x equal to 0. Suppose if you take x equal to 1, replace x equal to 1, b of 1 comma n comma p, in the formula you substitute x equal to 1, nc1 p power 1 q power n minus 1. Similarly, x equal to 2, b of 2 comma n comma p equal to nc2 p square q power n minus 2. Like that, if you substitute x equal to n, b of n comma n comma n, ncn p power n q power n. If you add all the terms left side, b of x comma n comma p, x where from 0 to n, x equal to 0 to n. This side also you add, this side also you add ncx p power x q power n. This is the expansion of nc0 p power 0 q power n minus 0 plus nc1 p power 1 q power n minus 1 plus nc2 p power 2 q power n minus 2 and so on ncn p power n q power n minus n. This can be written as p plus q whole power n. Binomial theorem which we have discussed in the intermediate level, this formula p plus q whole power n. What is p plus q, which is 1? 1 power n equal to 1. So that means the total probability in a binomial distribution is unity 1. If you add all the values from 0 to n in binomial distribution, we are going to get unity. That means the total probability in a binomial distribution is unity. Suppose if I take one problem, how to solve the problems on binomial distribution. See, a coin is tossed 9 times. A single coin tossed 9 times. That means n equal to 9. Find the probability. We require to find out the probability of getting 5 heads. What is the probability of getting 5 heads if we toss a coin 9 times? This is the problem. Coin tossed how many times? So the total number of events are n, like previous definition. We are going to find out the probability of getting 5 heads. So that's why head is a capital X. Getting head. Small x is 5 because number of heads 5. But to find out by using binomial distribution, we require P. P means probability of success in a single trial. Totally coin is tossed 9 times, but you find out P value if a coin is tossed a single time. If a coin is tossed 1 time, what is the probability of getting head? 1 by 2 only. That is P equal to 1 by 2. Q also 1 by 2. For single trial, P and Q. Now we need to find out the binomial distribution formula. P of capital X equal to small x is 5. That means probability of heads, getting head, capital X is getting head, getting head equal to 5. That means we are going to find out probability of getting 5 heads. NCX, where n equal to 9, C5, P 1 by 2 whole power 5, Q 1 by 2 whole power 9 minus. So P of capital X equal to 5 means what is capital X getting a head? Probability of getting head equal to 5. That means probability of getting 5 heads. So to find out the problems on binomial distribution, we need to identify what is small n, what is capital X, what is small x, what is P, what is Q. Then you substitute in the formula. Here capital X is the success, small x is the number of successes. P is the probability of success in a single trial, Q is the probability of failure in a single trial, N is the total number of trials. Now, we'll do another problem. 4 coins are tossed, n equal to 4. Find the probability of getting 2 heads. So, capital X is head. For the first problem, I am telling. How many heads? Small x is 2. P what? 1 by 2. Q 1 by 2. Why? Because toss, 4 coins are tossed, but you consider only single trial. Only one coin is tossed. What is the probability? P equal to 1 by 2, Q equal to 1 by 2. So what we require? 2 heads. P of x equal to 2. All values you know that na, NCX 4C2, P 1 by 2 whole power x 1 by 2 whole power 2, Q also 1 by 2 whole power n minus 2. At least 2 heads. That means probability of getting x at least, that means more than 2 or equal to. P of x greater than or equal to 2. That means starts from 2 up to how much? Plus 3 up to 4 only, because 4 total number of trials are 4 only. So that is P of x greater than or equal to 2 is P of x equal to 2 plus P of x equal to 3 plus P of x equal to 2. But all values you know that x equal to 2, x equal to 3, small x is 3, 4C3, 1 by 2 whole power 3, 1 by 2 whole power 1. P of x equal to 4, 4C4, 1 by 2 whole power 4, 1 by 2 whole power 4 minus 11. At least one head. Head is capital X, one head more than or equal to 1. That means 1, 2, 3, 4. Simplify it, we'll get value. Now, another problem. A coin is tossed 10 times, n equal to 10. Find the probability of getting at least 7 tails. What is capital X? Getting tail is a capital X. P 1 by 2. Q also 1 by 2. At least 7 tails. That means more than 7. 7, 8, 9, 10. Up to 10 only we have taken because a coin is tossed only 10 times. Now, see in the previous 3 problems, always we have taken P 1 by 2, Q 1 by 2. Because in tossing a coin, probability of getting head is 1 by 2, probability of getting tail is 1. But here, 20% of items produced from a goods factory are defective. That means P value directly given 0.2. If we choose 5 items, n equal to 5, total number of items are 5. Find the probability of, here what is X defective item? Defective item. So P equal to 0.2 means Q equal to 0.8 because P plus Q equal to 1. Now we need to find out none is defective. That means P of x equal to 0 you should find. NCX 5C0 because n equal to 5. None is defective where none means x equal to 0. Simplified will get. And 1 is defective. That means P of x equal to 1. Similarly, P of 1 less than x less than 4 means in between 1 to 4, which is 2 plus 3. Now, another problem. If 3 out of 20 types are defective, if we choose 4 randomly, n equal to 4, P also given 3 out of 20. X is defective item. If Q P equal to 3 by 20, Q equal to 7 by 20, 17 by 20 because P plus Q equal to 1. What we need to find? Find the probability that one of the defective X, P of X, how many? 1. Will be included, P of x equal to 1. We can do it by using the binomial distribution formula. Okay, thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.